Hello. Here I actually am. I'm sorry to anyone who tried to join earlier. I'm having trouble, as usual, getting to the double screen mode, which now hopefully I have all in place. We got my face here, now we got an iterated version, and we got our graphing calculator. So when I set that up, sometimes I set just one of those cameras and then glitch the stream. I need a tech wizard to join me, as me being more of a creative person than a tech person. But hopefully now we have successfully gotten onto our live mode so we can look at some really cool shapes I want to show you guys. I have a few equations here lined up, and I have a little activity first we're going to do. It's almost the new year too, so hope everyone's having a wonderful end of your 2022, whatever that means to you. And although our calendar is super random, there are better variations of similar calendars that I may be sharing in some episodes soon. On our next month, for example, we have a Friday the 13th. And on our Friday the 13th calendar, the way it works on our Gregorian calendar is any month that begins in a Sunday has a Friday the 13th. But there are some calendars that think every month should begin on the same day. And if you have some of those calendars set, some of them choose the first to be a Sunday, meaning there are some calendars where every month has a Friday the 13th, which is considered an unlucky day for some, but I think it's something we could spin into a more fun, lucky type of day. And so I will make a video probably coming out on the next month's Friday the 13th, which is hitting in January, about versions of calendars that I like more than our calendar model that use every month starting on the same day, which does cause a glitch. What it causes is that December 31st, as well as sometimes something like Leap Day, sometimes has to be assigned to have no day of the week. Sounds crazy, but imagine if you had a day with no day of the week. That would be an interesting type of holiday. So our calendar is pretty random, but it is the New Year's. One other thing that I did have to note, in case I don't stream tomorrow before the New Year's, which I'm not sure if I'll have time to do or not. I'll be throwing a party here with friends in the evening, so maybe I'll get a stream in before that or not. Well, tomorrow is a time on New Year's where sometimes there's this thing that's not only like Leap Day is this thing that happens earlier in the year, but sometimes they have this mini one called Leap Second. And I don't know if you guys have heard about Leap Seconds, but I think they're pretty cool. I think it's how you get us back closer so that each year's midnight is actually the same on December 31st. The calendar doesn't perfectly fit it because we try and put days to years, and the day cycle and the year cycle are sort of like an irrational ratio. So you need leap seconds to calibrate it, or you can stockpile and save up your leap seconds and wait until you're like a minute off, and then like once every some amount of years have a leap minute. Or you could go intense and wait until you have like a whole day stockpiled and just like get more and more off the cycle. But they deleted the leap second, or they are planning on deleting it in the near future. They said there will be no more leap seconds globally recognized by whatever council gets to be in charge of this stuff after at the latest 2035. So they're figuring out the leap seconding up till there, but then they're going to abandon the leap second because it's hard on the tech industry. The tech industry doesn't like that add a whole second thing. But however, someone who likes astronomy and likes the stars being in the mappable same spot at the same time would love a leap second. So I'm pro leap second, and I think that they may be making a mistake by kicking it out, but I'll wait to see what they're going to be doing with a leap minute, which will be the other alternative, and maybe they'll have a good enough variation with their leap minute that we'll consider it all right. Still, I'm going to miss the leap seconds, so don't think they're doing one this New Year's, but there has been some New Year's in the past where if you wanted your clocks to be as wannabe close to correct as you usually like them, Well, you need to add or subtract a second once in a while. I think usually you have one extra second occur, which means your clock would want to go back a second. Um, so leap seconds, RIP. We'll see what the leap minute has in store for us. Leap years, in fact, are a little different than some people realize. People associate it's every 4 years, but it's not exactly that. They skip one every 100 years, but then they don't do the skip every like 400 years or something. There's a bigger alternating pattern that's in place. It's not ideal. They could fix it. We'll make episodes at some point about the flaws in it, but they try and make it better than just a leap day would do. And it's not just leap seconds, it's also this whole protocol with when they do or don't do leap days. In any case, some of this stuff will be mentioned in an episode all about that calendar when next month's Friday the 13th hits. I'll also probably throw in some cat flashbacks in that episode because my cat Sassafras, the third one, the stray one that got adopted, was officially fixed at the vet, and so basically officially adopted on last Friday the 13th. I got a black cat on Friday the 13th. Some people would consider that double unlucky. Maybe it cancels out and turns to super lucky, like how two negatives multiply to a positive. So, in any case, those are some random thoughts about the new year hitting. I may do some more New Year's-y thoughts tomorrow, another stream or something while I'm setting up to throw a party in the evening. I've had some wild New Year's parties here in the past. Some of them, there's some wild footage you'll have to see someday. In any case, though, leave any thoughts or comments of anything fun you guys have planned for either a New Year's-y thing or any goals for next year. And one of my main goals is just to keep staying as productive as I've been on combo class, and hopefully that will keep skyrocketing us upward in combo lords, because we are past 84 point something thousand combo lords. Super awesome. Love you all. So, what we're going to do today did relate to a lot of graphing, because I was fiddling around on Desmos again and I found some more cool ones I want to show you guys. And whenever I start going down the rabbit hole of a family of possibilities to try, I sometimes cut myself off and I'm like, okay, we'll save it for the stream. We'll try these possibilities with the other combo lords. However, before I jump into the Desmos, I do have another warm-up activity planned. This is a sillier warm-up activity. And trust me, these graphs are going to be crazy and worth it, but I do want to do my sillier warm-up discussion-based activity first. And that is, if we were going to be talking about shapes, well, we're going to be making very strange-looking webs of lines and curves and stuff. But some shapes are polygonal-like, or little enclosed shapes. We could have also graphed something like x squared plus y squared equals 1 and gotten a circle. So what about shapes like this first? We're going to take a brief detour to a tier list of shapes. And we are going to discuss and rank some of these basic shapes before we move on to our crazy shapes. So, what we have going on here is let me shrink myself so we have enough room to put this all on the screen. So, what we got going on here is a weird ranking system they've made. They skipped D. They have S, which means like the extra top tier, even above A. And then you get your A, B, and C. For some reason, they skipped D and went to F. Whoever made this tier list decided that none of these shapes are D tier, but some of them are F tier. I disagree. I think we could have called some of these D tier shapes, but none of them are F tier shapes. However, I'll see if I can bring myself to even bring any in F. We may be only in S, A, B, and C, because it's going to be hard for me to put any of these simple enough shapes in F tier. But what we're going to do is, while I was looking at this, I was going through this website of all the tier lists and look up shapes and trying to find cool ones on numbers and shapes and math and random stuff. We did numbers the other day, and it led to me sharing some thoughts about single-digit numbers, and I think I have some thoughts about polygons and these other little shapes that I need to share while we talk about what it means to be a shape and which ones of these are over or underrated. Now, as usual, like with numbers, you could always make a more boring, arbitrary shape than one of these. Any shape that was like almost one of these, but with a little messed up part, or like something just with like exactly 47 sides or something random, could be more boring and arbitrary than any of these. And so we're not ranking them in terms of possibility. That's not possible. To rank them in terms of possibility, they would all be S tier pretty much because they're simple enough shapes. But we're ranking them compared to each other. So based on that, I'll try and put some lower toward F, but at least we'll get some in C because they're being ranked compared to their peers on this list. Now, we're going to go from the front to the end, I think, and circle the one I graphed. And you guys should leave your thoughts of if you see any shapes here that you either think are S tier shapes or that you think are F tier shapes. Those are the ones I'm most interested in. Comment is whether you think any are top of the line shapes or any you think are really boring, overrated shapes. So circle, I think a lot of you are going to agree, is an S tier shape. Oh, it looks black. That's hard to see there. Whatever. Dark on dark, we're okay. We know the circle's up there. Circle, and I think they'll all look like that probably now. Yeah, so it'll be hard to see them on there, but that's okay. Circle is definitely an S tier shape because it has a simple equation. A circular arc describes a lot of movement in geometry up through complex numbers or simple geometry. Circles are hidden all over. When you see pi popping up in all sorts of equations, there is typically a circle hiding somewhere. Circles are hiding everywhere. Circle, S tier. Heart shape. Now, this one is very dependent on if we mean cultural meaning or mathematical meaning. And we're going to have to sort of merge the two. Mathematically, this isn't the most unique, interesting shape of the bunch. It's cool, but mathematically, it's not like there's some pure function that represents this that's super important in math. The cardioid shape is heart-like, but this isn't quite a cardioid. This is a little different. However, symbolically, it's a pretty good one. You know, combo class, we're all about being loving to each other while we do our chaos. So, a good heart symbol does spread a good message. So we're going to put heart in A tier because I think it's a positive, good symbol, spreads good things in the world, but mathematically there are cooler shapes on the list. So that's getting to A tier. Now we're going to go to let's go these three together. Well, here, okay. We got to order by sides of amount of polygons real quick and go up the line. So here are our regular polygons. Regular polygons going up in size that they gave us. Equilateral triangle, S tier. Equilateral triangle is like the simplest perfect 2D shape. It's the face of many perfect 3D shapes. It can wrap around into tetrahedrons, octahedrons, icosahedrons. It's a very versatile shape, pops all over. Has some cool relationships to like square root of 3 is a nice number you can find in it, and other cool numbers. Cut it down the half, right down the middle. You get two copies of what many call a 30, 60, 90 triangle, if you're talking about degrees. You know those triangles, those 30, 60, 90s they're often called? Well, those ones are half of an equilateral triangle. So this guy gives us a lot of birds with one stone, S tier. What about a square? Now, a square is a really, really good shape. But I do think it's a little overrated, but it's probably still going to need S tier. I'm a little torn between S and A tier. The reason I want to drag it down is that squares get a little too much credit. Triangles and circles do a lot of jobs. Squares aren't the only important fundamental one. Squares are a little overrated. But they're really, really fundamental too. And the reason I'm going to push it up to S tier is just from their fundamental way of describing dimensionality. The way that as you scale something up in the second dimension, it scales based on a square proportion. And that if we were to be drawing these with dots as well instead, this guy is like triangular numbers, who I love. And this is like square numbers, who I also love. So square is going to get S tier also. These three are pretty important, fundamental. Those three get a lot of jobs done. However, I can spot one more that is going to get S tier on this list. So that's another thing you can leave a comment. What's your guess on the other one I'm going to give S tier out of this list? I think only one other is going to make it up there. So how well do you know me? Which one of these is my favorite? Now, let's go down the list of sides of regular polygon, and a pentagon is not quite S tier because it's a little weirder, little less common, but it can wrap around in 3D to make dodecahedrons. It does have the golden ratio hidden all over it, so it's getting A tier. Hexagons. Hexagons can't wrap around in a 3D shape in the same way, but they can tile the plane. Only equilateral triangles, squares, and hexagons out of the equilateral polygons can tile the plane. So these also, if you cut them down into 6 pieces, you get 6 equilateral triangles. But I don't know if that gives it an up or a down, because that kind of is like cool, but that kind of is like, we already covered that with triangle. So it's sort of an 6 equilateral triangles in disguise. Now, it is so cool and relates to the equilateral triangles and to plane tiling, and it has important angles in it, that we're giving it A tier. We're putting it up there in A tier. Now we get a little weirder. We get to the heptagon, the 7-sided regular polygon. Now a heptagon's weirder. It is the first regular polygon that's not constructible. Now, if I was like, I need it to be constructible, that would give it a minus maybe if I was in ancient Greece and really wanted to use my compass and straight edge. But I think it's kind of cool mathematically. There's a lot of cool reasons why it can't be constructed. And in fact, I'm kind of, I have a few ways of presenting this planned for episodes. And it's either going to show up as one episode about like 3 different ways, or maybe even 4 different ways of explaining in completely different reasons, or what sounds like completely different reasons, why you can't make a heptagon with a straight edge and compass. But if I don't get that episode, it might just show up in a bunch of episodes where it's like, here's another reason you can't construct it. Here's another reason. Because weirdly enough, let's get a little sneak preview of that. Heptagon non-constructible. I just want to go through a few of the reasons that are really weird about this. Where are they doing? So here's them drawing constructions. Where's a heptagon article is what I wanted. I want to see about just the heptagon. Yeah, I'm not seeing the visuals I was hoping for right here. I'll find the right visuals when I make an episode about it. There are cool ways to explain why it's impossible by tapping into many different possible fields of math. So back to this, I think that its lack of constructability and it being like weird in a few senses in terms of the shapes makes it kind of cool, but it's not like an A tier shape, it's a B tier shape. The octagon being having some cool powers based on its side amounts being a power of 2. 2 cubed is how many sides it has, gives it some traits, is also a B tier shape. They didn't have a nonagon on this list, it looked like. A nonagon would have gone C tier probably. Nonagon's when it starts to get a little more random. Now, there would be ones with a bunch of sides that we'll get into this in the constructability episode, but there are some shapes like a 65,000. I think this is right. It's something along the lines of 65,537 gone. Yeah, that's it. See, why would they have a Wikipedia article and a Wolfram Math World, which is another good site, article about the 65,537 gone? Well, that one is constructible. Is this going to show the constructability? Yeah, this is an example of one of the things I wanted to show. It's kind of hard to see what they're doing, but they're making like really, really big arcs of circles and these crazy combos. Yeah, we probably won't construct 65,537 Gone ourselves, but we will look into how that surprisingly would get a higher tier than like a Decagon. I would put Decagon C tier and this B tier. Actually, this is A tier. It's cool that it has that many sides and it's constructible. But that's not on their list. Wait, maybe that was. Maybe this isn't a circle. Maybe this is a 65,537 Gone. We wouldn't be able to tell the difference. So, okay, circles back in S tier. No, yeah, go to the front of the line circle. Oh, you could even sort them in the tier, but they're unsorted in the tier for now. So, let me see if any of you have any thoughts. People like the hexagon a lot. So, and the heptagon. And someone didn't like the heart. Well, this is my ranking. I'm sticking with it. Thank you for your feedback. Keep leaving comments on if anyone has a guess of which other one of this is going to be my S tier. Now, oval, also known as an ellipse. Cool shape. Kind of a wannabe circle, but still pretty cool. We're going to give oval / ellipse. I don't know if I should give that A tier or B tier. I'll probably give it A tier. It's a wannabe circle, but it's doing a pretty good job. How about this parallelogram that's not a rectangle? So here we got a parallelogram, non-rectangular. Now that's, when we're ranking these guys compared to their peers, that's a C tier shape. That is not the best of the bunch. Kind of cool. They make you learn about this fella more than they should in school. Or at least I did. I don't know what was the deal with this guy being so popular. He's cool. Nothing wrong with him. But it's a C tier compared to the peers. How about a rectangle? Someone mentioned adding vectors. Yeah. It does look kind of like that. Although these ones are... Yeah, we have like a completely straight one in this case. But yeah, it does look... It is vector, like it's still getting C tier, sorry. Rectangle is getting B tier, because that's a little more notable. Shows up a few more. Okay, rectangle can get A tier. No, rectangle's getting B tier. But I feel, yeah, that's true, because although circle and square are both S tier, circle's better than square if there was an even higher tier. So wannabe circle gets to go higher than wannabe square. Because this is a wannabe square. Doing a good job, still B tier. So how about this fella? This rhombus thing. Also sometimes called a diamond. Now rhombus is kind of cool, but I need to put some in C tier. I like the rhombus. They can tile planes, and a bunch of them can. They're cool, but no. C tier. There's better shapes. Now, this star, here's the thing. If they had connected the lines, if they had made it like that, if they had connected the lines, I would have given that A tier because it's cool. It's like at the point where this polygon is called 5,2 on some ways of notating it, because it's like you have 5 points. I went to the one 2 away. I did a version of that in an episode. I didn't talk about the terminology of the star polygons, but in my episode where I'm like, and then you go 2 away on a circle with 5 dots, we got one of these. And this shape is cool because when you have 5 dots on the circle, you get more options. You get a pentagon or this. Smaller ones didn't work as cool. So this is the first time where you get this like alternate star version of a shape. And that would give this a solid A tier. However, they didn't fill in the lines in between. This shape without the lines filled in is not nearly as good. Now, it still gets a cultural point because it looks exciting and fun, and a star is like, let's do something cool, fun star for something. So I'm giving it a B tier because it looks fun and exciting, and I would want to, like, if I saw a bunch of those somewhere, I'd be like, someone's decorating cool, they're having fun. But it should have those lines in between. Mm-hmm. Now, sorry to the trapezoid fan in the comments. Trapezoid's getting C tier also. They're kind of cool, but it's not the best of the bunch. And that leaves the right triangle. I'm not sure if they were intending this to be the one known as the 45-45-90, which I think the better name for is the isosceles right, because it's the only isosceles triangle and right triangle combo. I don't know if they were intending this to be that or just to be a right triangle. They didn't draw the thing that shows right, but they didn't draw any markers on the others for angles, so it makes sense. Whether they meant the 45-45-90 or meant just a right triangle, S tier. Especially assuming they just meant right triangle, I'm assuming, maybe. I don't know. Right triangles are S tier. They're everywhere. They're the distance between coordinate points. The ones with whole numbers for sides have so many beautiful patterns. Pythagorean triples. And yeah, the Pythagorean theorem in general shows up everywhere. It's a mutated version of the distance theorem. This is everywhere. This is S tier. And I wasn't able to bring myself to put any in F tier. All right. And someone's wondering how the hell is Hexagon not S tier? I understand the logic because hexagons are really cool, but here's the reason why it didn't go to S tier. Is because if you cut it in 6, you get 6 equilateral triangles. And while that's really cool, the fact that we have a triangle in the club means that this guy and 5 copies of itself can make this. So the fact that equilateral triangle was also in the batch and a bunch of them can just compose one of these made this not quite as special. But it's still a great shape. It also can't wrap around as the face of dice as a platonic solid type shape. Really close though. It would be on the edge. So, someone asked about straight line. Someone said reported for being wrong, hopefully joking. Don't report anyone, whether you're talking about me or a comment. No, reporting people for joking. But a straight line, that would well, I don't know. Do you mean line segment or like an infinite one? Um, it's kind of an S tier. You know, like a line's pretty powerful, or a line segment. A line segment's like the only 1D polygon. I mean, technically it's called a polytope at that level, but the only 1D polytope. And because one dimensional is a line, you know, and a line like is the first dimension. So line or line segment are kind of S tier. Now, this is our time to transition to seeing some even crazier shapes. So after our warm-up activity, of course, we're flipping over to our friend Desmos, where we can create wild shapes. And whoever mentioned point, that is definitely an S tier as well. Point is total S tier. Point is like the equivalent of the number 0. And the number 0 we saw in my last tier list is totally S tier. Now, today what we're going to try is a few families of function, but we're also going to be using inequalities, which I forgot to use sometimes, which is when instead of saying something like y equals sign, I'm going to say something like y is less than or equal to sign. And then I get the color of all the places that's true and a line on the barrier. So here, for example, we have when y is less than or equal to sine of x. But if you experiment with things and get weirder, you get kind of more interesting. What about sine of y is that? We get this checkerboard. And if you look at, like, it's not lined up with a side length of 1. Where does it hit right there? Looks pretty pi-like, doesn't it? 3.14 maybe? So you'll notice pi sometimes as the places things hit if we don't neutralize it. If I put a pi in there, I actually think I've made the side length now just be 1. Yeah. So that was just our starter experiment. This isn't the graph we're doing. This is just kind of my demonstration of inequalities and a reminder of this is a sine wave. This is a cosine wave, very similar. And if we ever do tangents, they go like that. And what if I said something like, well, let's go down to our interesting ones that I've set up here. Now, these are all ready to go. I just haven't clicked their color yet. And what we're going to do is, first we're going to just go down and look at these, because they're really crazy. And then we have two ways. Oh, I forgot to put a plus there. We have 2 ways, or I guess multiple ways. One way we could try experimenting is like removing the pluses, making this side multiply instead of add. Another way we can experiment is by replacing these signs with things like cosine and tangent, or other functions. And another way we can experiment is by sticking letters A and B in these in random spots and having a slider to move a variable. But first, my favorite part of when we do this is how simple of an equation you can use to make complex beauty. I don't mean complex like complex numbers, I mean like complicated, but you can get really elaborate patterns from really simple things. So, like for example, we saw just that sine is kind of repetitive. It's a beautiful little curve, but it's a little repetitive. And if I had just said something like x plus y equals, well, x plus y, that would do nothing, right? And this is sort of just a mutated version of that, where it's, and by nothing I meant everything. Everything would fit that, I guess. But this is just putting sine x plus sine y separate, and then sine x plus y together. Very simple type of way you could imagine seeing what points fit this. That the sine of them separately, which ones is the sine of them separately less versus more compared to the sine of them together in there. Well, we get this half-checkered thing. We get these parts of the grid are where that's true. Now this one's very simple. Don't worry, the other ones are crazier. The reason I set this up is because when I was fiddling through, I was like, let's try and make these all similar and see with this slight variation how much absurd, strange beauty will emerge just by changing this last bit from x plus y to either x times y, x to the power of y, or x divided by y. And here's x times y. Look at that. It's like somebody spilled a glass of water and it did something really beautifully symmetric. Now, as you go out, they give us this warning. This equation contains fine detail that's not resolved. So these little blurry bits are it not knowing exactly what's going on there. But when we zoom in, we see, oh, it does have this beautiful, strange pattern of where there's gaps and where there's not. We're wandering this landscape, and then, oop, I came to the spot where the water spilled. So, as a refresher, this is x plus y on the side. This is x times y on the side. What about x to the power of y? Now, if we had started over here, you'd be like, oh, this one's boring. This one's another one of those checkerboard ones. But as you go toward the shore of the board, you start getting this really... That's not actually that fuzzy. It just can't handle what's going on there. It gets really quickly back and forth right after. It looks like as soon as it passes 1, it starts getting really crazy under 1. This sort of reminds me of the Riemann zeta function, where that one's like literally impossible to do under 1. They diverge to infinity. But this is reminiscent of that in a weird way, of this strip from 0 to 1 that's weirder than the rest of it. And the Riemann zeta sum is this $1 million question. I will be making a video about it at some point. And yes, it is literally $1 million question. I am not the one who gives you $1 million. It is someone called the Clay Institute of Mathematics. So look at these. This is wild. As you go up from the checkerboard, you hit this weird realm that it can't comprehend it. It's like way too busy in the realm. Wow. So, now let's see x divided by y. You guys ready for that? Now, this one was one of my favorites that I found here, because look at this. As you zoom out, you have a few things going on. We have this middle highway. You see this curvy highway that's too jumpy for the graph to figure out. At no point will I zoom in at the middle of that highway and have it fully detailed, because it just gets smaller and smaller and just can't comprehend it. So that highway gets infinitely dense on this one, not straight highway this time, a curvy highway. Up and down and up and down. But then here's what's extra weird. Outside there, you get these big regions where down here it's mostly like the white backdrop, and here it's mostly the purple backdrop. But you get these little extra rays. What's up with that ray of white coming in from the side there and going down there? Or the ray of purple that goes down there? Do you see? Isn't that really crazy? What is up with this one? Now, I found that I liked it even more when I deleted the plus. Look at that. Sine of x times sine of y. Now, just to see what we're looking at, if we just said equals, this is if we just said sine of x times sine of y equals sine of x over y. These are the points where that is true. absolutely insane. This is one of my new favorites. Oh my god. Whoa, what's going on? I can't comprehend all these little dots or something. Whoa. Okay. This one's so cool. Remember how I wrote an equation on my wall the other day because it was that notable? Well, I'm going to write this one right under it. I think the whiteboard marker should probably be good enough. So, do you guys see the sine x plus sine y? That one's our last classic. This is so reminiscent of that. I need to write it. Times sine of y. Equals sine x. You know what I should start doing? I wonder if this will get all the mathematicians mad. Instead of x over y, what if I start calling this x-withs? You know how you say like 3/4 and stuff? We can start calling this x-withs. So that'll be our new combo class way of saying that. And similarly, you could say a-beths is when you have a over b. You got a-beths right there. So this is a magnificent one. I don't know if you guys can see that, but I just wrote it on my wall next to the other sine equation we wrote the other day because it reminded me. So then we put the inequality just because it fills it in a nice way. These are the spots where it's less than or equal. We get this like rivery pattern. Now this is crazy. It's like these different beaches colliding at a highway. So there's that one. But now what we're going to do to make this... Well, first let's just see what the others look like when we turn their plus into a times. Zoop. Oh, we need to zoom in on this water spill one. This is the one where the water spilled. Alright, and if we turn that to a times... Nope. Whoa, that straightened it. That's because we want to change one variable at a time. We found a cool series of different types of thing that, since these all have different levels of games they like to play, we can choose one variation and plug the variation into all four. So for example, our first variation is going to be, what if I replace all these signs at the end with tangent instead? And we're going to see if that makes it go crazy on any of these cases, what that looks like. Here we get our first one. Pretty cool. Here we get our second one. The water spill looks different this time. Cool. Here we get our third one. And this is a strange new type of checkerboard. This one just gets hyper glitched right there. Ooh. And then we get grid-like right here, and then the grid like dissolves and turns all weird. And we get like a wannabe grid creeping in on the side right there. So there's that one. And what about one last one? Whoa. That's crazy. I already love this one, but it gets even crazier maybe when we put the tangent in. Look at these crazy rivers joining and meeting. Okay, so here's what we got to do next to make it extra crazy. Is we got to try and put a variable into these. I'm going to put these back to sine for now so we can start from scratch with each of them. And we're going to sneak a variable right inside here. This one, we'll put it around all of it inside the sine. We're multiplying each of them by a now. So here's our slider for A, and this is going to have control over all those A's, whichever one we turn on. When A is 1, since we put it in a multiplicative way, it's not going to change anything. A being 1 is how they looked before. So this is that one how it looked before. We're just zoomed out. But now we can change A. So looking at the comments real quick. Can't answer too many comments today. We're mostly doing cool games and stuff. But thank you for leaving them anyway. Some of the comments I've just answered recently of questions. Feel free to always leave more. For now, what I want to show is if we morph the A, things change. Oh, that's strange. Whoa. Whoa. Oh, look, for a minute they formed these individual bands, and then they're back together into these jigsaw-like things. Ooh, and then now they're an individual, well, kind of an individual band. Whoa. Some of them are in doubles, and they're going in weird streams. Wow. Whoa. That's a weird realm. Whoa. These are cool. And then, yeah, we're just on negative version. Okay. Whoa. We hit some weird ones. What was that rectangle? Or yeah, squares again. When we're at 0, we get squares. When we're at -1, we get half of those squares. Same with 1. And then we get these other weird ones. So, that's that fella adjusting just with A, multiplying an extra variable there. Oh, we want A back to 1. This is how it was in our water spill. And now we can evolve our water spill. Whoa! Oh yeah, we hit squares when it's 0, because whenever we're at 0 on any of these, they're going to make them the same, because it's going to be sine of 0 on this side, and that side's the same. So all these equations do have a time where they hit the square, when it's 0. But then they have other weird ones. Like, look, when it's 0.1, look at this. Sine of x plus sine of y is less than 0.1 of xy. Is this. Whoa. That's wild. Okay. Next runner-up to bat is this fella. And how is this going to change when we fluctuate that constant? Ooh, the craziness is pushing the grid back to itself. Ooh. That one's hard to observe the change, because these ones are just chaos land. So, one more. Oh no, we're at -10. Whoa! Maybe that was what the Big Bang was like. Look at this craziness. So, let's go back to 1, wherever that is. Where was 1? Okay, this is where we started. Now, let's see what happens when we add it. Whoa, this is so trippy. Whoa. We get like polka dots in the middle, but that might just be Desmos trying to see crazy spiky shapes. Whoa, we go in and we get these flower-like petals. And this infinite highway. Wow. Whoa. Alright. So, wait, one more test was what happens when I mess around with it when they were multiplied. Remember this multiplied one that's really cool? Well, now it's going to be able to fluctuate. Whoa. This is wild. I'm cascading down into the vortex. Look, right now this looks kind of like a little face. 2 eyes and a mouth. It's like, this looks like Finn from Adventure Time. Hey, I'm Finn. Alright, so there we go. Now what we're going to try next is we stuck an A there. What if instead of an A there, no, we don't need these parentheses anymore, we stuck an A or something else somewhere else? Or also, what if we changed the other ones to tangents? Forget our A for a minute. We haven't tried changing these to tangents yet. First, we're just going to try Y, and then we're going to try both. Now, trying just Y versus trying just X, we might try to, but there might be some of these would just have a symmetrical, just flip version. This one might not have the same symmetry if we flipped it. So there we get some ocean waves. And, you know, let's maybe put that A back in just so we can, like, see how well we can control the waves. Yeah, oof. This is like when you're surfing and it's going crazy. Felt like this when it was pouring rain in the combo classroom the last few days, but it wasn't really going wild. It was more just like wouldn't stop sprinkling. I did film a lot of crazy stuff with bubbles while it was wet out yesterday. I made homemade bubble solution with one of my camera guys, Carlo, and we made some really big bubbles with like using clock parts and dish soap and all sorts of stuff. So the next main channel episode is, both of the next two are rainy day ones, but one of them is pure math and then one of them is bubble fun. So those ones will be coming out not this year because it's so close to the end of the year, but next year you can catch those episodes very early next year. So there's some waves going. And what happens if we try that to the more interesting functions down here? I'm going to sneak the A back in, but set it to 1. Remember, when A is set to 1, it's like A doesn't exist. So, whoa. That's what happened when I replaced the tan. So remember, we haven't tried these fellas with the tan in them yet. Now, if I move A, we get really wild types of waves. This is a different type of beach. Now, what about this fella? This one just lives over here. Oh, we hit a moment where it was calm. Yeah, when A's 0, that's the new equal point that they're all going to look the same. Looks like this is what they all hit when A is 0. Because that's when the sign, when the right side is sign of 0. So this is a weird ocean. It's like, in this ocean, it's like, okay, you're surfing here in the water. And if you go close to the shore, there's a bunch of sand. You see the sand on the shore? And if you go upward, you get to the dangerous part of the ocean. Up here. And if we really see what's going on in one of these glitchy parts, it's these like really fast sets of curves that are giving Desmos trouble. So we got one more here. Okay, sin X, that's even just with 1. That's before we've even done anything weird to it. That's just switching the tan in. Oh no, that's we forgot to put the plus back. We took the plus out. Okay, still pretty weird. Now, the fact that taking the plus out was so cool makes me want to take the plus out on these, too. Ooh, that's interesting. Hmm. Oh, that's trippy. Whoa. It's like a frog or something. Okay. Okay, a little more interesting, maybe. Alright, we'll keep them multiplicative for now. We're having the left side multiply for now. So, what happens when this one moves? Woo. Oh, what did we hit there? We hit rectangles. This is a new 0. When sine of x times tan of y is less than or equal to sine of 0, then it makes rectangles. And the rectangles are pi long, I think. Pi long by maybe half of pi tall? I don't know. Alright, so there's those ones, but there's a lot more wildness we could do. Whoa, these are super cool. I love this bottom one where we divide it. Things just get so cool and crazy. This is awesome looking. But there's a lot more we can try. One thing we can try is moving where A lives in there. But first what we're going to try is just adding the other bit also having a tan on it and going a little extra wild with both of these sides on each being tangent. And let's set A to 1 before things get too crazy. So, that's if they're both tangent. I actually liked when only one was tangent more, maybe. It's like a super weird chess board. Someone should invent a game that uses this board. The board changes like this. Wouldn't that be cool? If your chessboard changed like this. Like you see, like, if I'm like up here and I'm in this cell, then when the board changes, if I see the board going this way, I'm like, okay, now this is the same space. That'd be cool. So, lot going on in this one. That one's pretty wild. And we hit our normal grid. Whoa. But that's just the start of things. So now what we're going to try is we're going to put these back to signs, but we're going to try giving them, let's give them a B. We'll give a new slider for B. Sine of bx, sine of by, sine b, sine bix. This one was signed by this thing. Now, B is 1, so it hasn't changed anything yet. We're going to put A back to 1, so A is not doing anything yet. Then we can see if we want to morph A with B or keep A as 1. What happens when we change B? Is that just scaling things? Yeah. Maybe I shouldn't have put it on both. Maybe I should have only put it on 1. Is it just going to scale things here too? Well, it creates things with the scaling here, so it's not just scaling, but let's try it on just 1. Oh, now it squishes it. Okay, let's try this. To the power of B. Now it depends which power it is, if it goes left or right. Whoa, what's going on here? Too much to handle. This is a weird one. This is a weird landscape. This reminds me of the bubbles I was making yesterday. Seriously, it reminds me of the bubbles. This one's interesting and strange. Huh. So, we got too much going on in here. I started going crazy. But I like that idea of this being our left-hand side. A is 1, so remember A isn't doing anything. It's as if A doesn't exist. Oh, that's interesting. Oh, that's boring. Whoa, what's going on? Look at this. It's like, oh, my nice boring wallpaper. Ah, but what's happening here? Oh, not so boring am I? So that's pretty wild. Okay, I actually really like this one because it's like a trick one. When you look at it from a distance, you're like, boring. What happens when I set it like really low, like -10? Did that even change anything? What happens up close when I'm doing those extra distortions? Well, that was a new one. What's the simplest one that has that weird trait? Here. So like you have all of these like stalks of a plant or something and you're like, alright, all my stalks look straight and normal. Wait a minute, one of them has something broken on it. What's that? It's a whole world! So, that one's kind of cool. Now, let's try this fella. And wow. You never know where you're going to get that. Some of them have an infinitely dense part. And like this one gets like too dense to handle over there. Whoa. Whoa. Too dense to handle over there. This is just tripping it out. It's just getting confused over there. But it's also too dense to handle in the middle. So, if I want to zoom into here, I have to like approach it from the side. I have to like come at it from this angle. And then I can like fall down this infinite hallway of pebbles. Now I'm like in the zone, you see? That's where I was. Alright, time for another. That one's pretty wild as usual. These might be getting a little too much for it to comprehend on so much going on the equation. We might need to give the computer a little easier time next. Okay. So. We forgot to move the B on the last one. Whoa. Whoa. Don't fall down that portal. Whoa. Okay. So now we're going to need to simplify things a little bit. We got pretty crazy with all of this. X to the B, Y to the B. And I changed my mind. We're going to go even crazier. We're going to go sine of X to the Y and sine of Y to the X. So that's what we're going to replace it with. Sorry guys, we're going even crazier. So let's remember B doesn't exist anymore. A is set to 1, so it's like A doesn't exist currently. Whoa. Let's even simplify this. What if we just even make this 1? Is that this part of the grid that's true for? What if we make that X? That what? What? Wait a minute. That's weird. What's going on there? That's trippy. I'm gonna have to look into why that happens. That's interesting. Yeah. Huh. Ooh. Whoa, this is like a new type of crazy flower-like shape. It's like a palm frond. Whoa. That's pretty wild. Okay. So. Pretty wild. What about this landscape? Whoa. They're having trouble with these ones. Whoa, that one's super irregular. That's weird. This one says like, is that a really big gap there? What's really going on here? What if I was going up this river? Is that really a river? Yeah, I'm like going up this river. I'm dodging the stuff. Going up this river. Okay, now they're having trouble showing all the stuff. I'm trying to dodge all the stuff. Can I dodge? Yeah, so it's hard for them to show all the stuff. But it looks like there's like this river cutting through. So that's interesting, these shapes, these little pockets. Look at this big pocket right there. It's a little lake island thingy. That's pretty cool. And there's something similar to that weird thing from before missing. Oh, and we can morph it. So yeah, there's like a whole band of rivers ready to go. That's weird. Whoa. So, what else is on the cards? These were getting pretty complicated. So, we don't necessarily need both of these on there. What if we just try this? That's already crazy. I should have put less than or equal though. So yeah, sine of x to the y is less than or equal to sine of x times y is already more than crazy enough. Yeah, can't comprehend this one. What are these ones gonna be? Whoa. Yeah, these are just like way... Oh, no, maybe that's because A is -10. Was that why? I had an A in that one. No, this one didn't have an A. It's still absolutely insane. Yeah, we'll take our A's out. We'll put A somewhere else in a minute. So yeah, these simple equations are... Well, this one's now the same. We need to say y to the x there thing to make that one different. Oh. This one's trippy. Got a little back and forth. Whoa. I wonder if we turn these into x times y. sine of x times y is less than or equal to, and let's even just turn them into equals now, because I just want to see some of these simple like line type ones. Sine of xy equals sine of x over y. So it's just crazy that these are all the points on the graph that holds true for. That the sine of the two coordinates multiplied together equals the sine of the x coordinate divided by the y coordinate. These are the points on the graph where that's true. Crazy. What about here? Okay. These are the points where sine of xy equals sine of x to the y. Ooh, I like how 1 just has bullet going out. Look, y equals 1 is just like, yup, I'm making this thing happen. I'm staying here. So, yeah, y equals 1 is your steady, consistent guy in this chaos. Well, as long as x is positive. And then, yeah, you get all sorts of weird messes in this one. Whoa. So, how about here? This one is just going to be not work. That is the same thing on each side. So is that one. This one is just a plus. We've gone back to ones we've seen before, but this is already just so simple and crazy. And A, yeah, A just stood for my ability to add a constant, like an extra number multiplying by stuff that I get to pick. Like here, if I say equals sine of xy, then that won't work because these were too similar. X plus y. That didn't work either. Oh no, it's because he's turned off. So here's where sine of xy equals sine of x plus ay. X plus a. So how about this one? Sine of xy equals sine of a times x to the y. A changes are different amounts we could put on it. Now our inequalities look pretty cool. Like when we made it less than or equal. That's good. And then if we put an A there, this one can sort of smush. And what if we put it on both sides, weirdly enough? All right. Feel free to leave any suggestions of other mutations you want to see. Now, one thing we were trying earlier, I'm just clearing the board, was sine of x. Clear the board. Sine of x plus or times sine of y equaling the sine of x over y was one of my favorites of the new ones. And one thing we can always try to make this crazier is squaring something. So we're gonna have to try throwing maybe even a to the power of a on a few different places. So when let's do this. Since they start at 1, we're gonna give a few different sliders. So this looks crazy, but it didn't change anything yet, adding those 4 sliders. So now I can adjust one of those. And for example, if I go to 2, this is if I have D. If y was squared at the bottom down there, it makes these grid-like shapes as you go further and further out. I'm on a grid. No, I'm not. As I change it to other powers, it fluctuates on if it's on both or neither. Feeds around. Whoa, this is totally different when it's negative. Completely different behavior. Whoa, what's up with that? Look, straight lines at, it looks like pi amounts apart. Whoa. one that we started with. Now, what if we made a different variable change, like the C up there? Now, the in-between steps are weird, so here's what we're going to do. We're going to make the steps just go one at a time. So then we're only going to have integer powers. Now if I change it, it's like going squared, cubed, etc. Like one clear increment at a time. So C, 2, okay. That's if we had squared the top bit. Whoa. Whoa. That's wild. All right. Now what about further? Cubed, fourth power. Whoa. Now we have like this straight like highway, this like weird railway going down the middle of the map. You see how that railway stays pretty constant? Whoa. Oh, and if we go all the way over here, we just get this super packed highway in the middle of a grid. Like this super busy, crazy highway in Grid City. And here is our center. This is like where all the freeways collide. Alright, so now we'll set C back to 1. And this is where we started. And now we can adjust B. Whoa. That got pretty weird pretty quick. Whoa. Ooh, it gets simple when it's -1. It looks like these two channels of energy coming together. And then they're like, and then when they hit, they go, whoa. That's when we're 0. So wait, interestingly, when B is 0, that means this turned into just 1. Y to the 0 is 1. So replace that with a 1 there. And there's where we started. Now one more variable to tweak. And that one, as usual, gets really crazy really fast. Because I've added my steps to be just the integers on these. Whoa. That's pretty wild. It's like, which direction of energy do you want to flow down? Whoa. Alright, now after we reset them to 1, we're going to try a really simple switch. What if we put a plus right here? Completely different. Now we have, look up here, down here, we have this zigzaggy line. You see this zigzagger? This zigzaggy line's funny. Look, all the way down here, it's getting closer and closer to being part of these squares. Look, all these are separate squares. They're close. They almost look like a checkerboard grid at points, but they're not. They're separate little squares. And one zigzaggy line. This one line is just going, well, technically a curve, not a line, but and look, this one's going all the way up here, and you're like, is he going to go forever? Well, something might happen when he hits the origin, and he goes, I've hit my end. I hit the freeway. The line ran to the freeway and collided, and a different shape took precedence. This is a cool landscape. All right. And whoever said they could lose themselves in here for hours, you should. And you should, at some point, comment your favorite ones you've found. Or save them up for next time I stream on this theme. This is a theme I like to do once in a while for the live videos. Planning a few crazy graphs in advance and then just fiddling around with them. So here we can change all the variables again because we added a plus. Now someone also did ask about if we can put things, like turn one of them to a tangent, and we definitely can. That is the other main type of mutation we may see in the near future. Whoa, this time the zigzaggy line does a different thing. Oh yeah, the zigzaggy line's back. Look at Mr. Zigzag. I'm the zigzagging line. I'm the zigzagging line. Wandering toward the origin. This time, last time I hit the freeway and I died. This time, I do a weird loop and come back around and I start doing this thing. And now this is me. So that's a different tale for Mr. Squiggly Line this time. So these are pretty awesome when we fiddled with that one or two more before we throw the tangents in. This is different actually. Whoa. Yeah, this one left some strange gaps and spaces. Whoa. Bunch of teeth. Ah, pretty cool. Well, all right. So it is true. That's if we set a 0 is kind of interesting. But yeah, back to 1. Now they all mean nothing because they're all 1 and they're all multiplicative or exponentiative or whatever. So what we're going to do here is, like someone asked, see what happens when we turn one to a tan. Remember, these are all doing nothing right now. So here's tan with a plus there. Ooh, and look, my zigzag friend returns. I'm a zigzagging line. I'm a zigzagging line. And I got to the middle, and look what I do this time. The zigzagging line does a whole new pattern. The zigzagging line becomes a whole checkerboard. Look, the zigzagging line's now covering double squares. That's a hard-working line. It used to just be covering like half of each square. Now it's like, I'm covering 2 squares at once. Let's see. Someone's saying we could put absolute values into part of it to cause some interesting properties. And that might avoid that flickering that happens when you do exponentiation. That could help to throw absolute values when we do the flickering thing. I think that sometimes the integers also help the flickering, but like when we make the steps to 1. I might save absolute values for another day, but those are a good one we can throw into the mix sometime. And what happens if we edit any of the others? What happens if instead of this one being tan, this one was? Interesting. Intriguing. We can also put our less than or equal on again. Okay. We need to return some of them to signs. And now we're going to change some of these fellas again, now that we have all of that in place. This is really close normal. These look like chess pieces, sort of, from afar, don't they? Look like some chess pieces are made, and then there's the chess board. Chess board with a little glitch. You're like, okay, I'm playing chess, cool. Uh-oh, something going on there. Whoa. This would be a cool chessboard. That's a whole new story for a chessboard. And people are interested in inverse trig functions, as well as someone said they tried it with phase offsets. I'll go through and check out all those cool comments from the Sentinel guy or person commenting. But I don't think I'm going to try them today. I'm going to be only streaming for a little bit longer. Just wanted to fit in a nice rainy day, technically. Computer stream to show you some of the ones I'd found and do our little tier list in chat. So I'll have to try the phase offsets another day. Let's see. That changed things pretty weird. What's going on at these phases? That's interesting. Oh, stalactites and stalagmites. Okay, now I was just having trouble seeing anything. We're putting it under too much pressure. So, I think that I'm going to wrap up pretty soon. So one of the last things we'll try is when we tried looking at polar coordinates were pretty fun. And let's set a biggish range for it to spiral to. There we go. What happens when we did things of that? Sine of theta just gave me a circle. And if I did sine of theta, sort of smushes the circle. Here I can bend the circle. And I can continue bending the circle. You see that weird way it's pushing the shape, sorta? Alright. Too much for it to handle. And here's where we got our bugs. Look at that butterfly. Alright, and thank you to all the people leaving the nice comments. Much love to all of you. You're all super awesome, and hope that if you can't catch me tomorrow, which I'll probably do a stream, that whoever doesn't catch that has a wonderful new year. Even if the calendar shift doesn't really mean anything, you know, spiritual or astronomical, just when our calendar happens to switch. It still is a time where you might as well celebrate and come up with some goals and come with some things you're proud of. Why not? Let's see. Yeah, thank you all so much. I think that pretty soon I might go to switch off of my stream, work on some writing, and eat some food and such. But I do have plans to probably stream again at some point tomorrow with a celebratory mood for the new year. I didn't do a New Year's special on the main channel. Like I said, on the main channel, we got a super mathy rainy day one coming, and then we got a bubble science rainy day one. But I didn't do a New Year's special because my calendar stuff made more sense to save for Friday the 13th that's coming in January. Um, so the New Year's special will be on the bonus channel, some sort of stream tomorrow there, or something casual like that. In any case, let's enjoy this bug flapping. There's a little bug flapping. And if anyone has any last thoughts or questions, leave them right now because I will be logging off pretty soon. We'll be doing more graphing and madness on future days. And like I said, I will try and announce a schedule in the new year, which is just now about barely more than 24 hours away. In the new year, I will let you guys know which days and times I'll be streaming. So you'll have a schedule. It won't be for all my streams because I'll do them at random times too. But there'll be at least a couple days of the week that I will note down as particular times you can expect. There might be a couple of the days it's on Twitch too instead of YouTube, just so I don't have to care about copyright stuff as much. Like I can do more stuff where you see my computer and I'm not as careful about what websites I go to or videos I show or stuff like that without getting something flagged for copyright. I am in love with my YouTube channels and I wouldn't care if they took down some Twitch channel I make. So I'll keep you guys tuned about that, but I'll also have some days on here which will be the classic types of stream where we do wild graphs, bonus math facts, rare stories from my life, and science experiments and stuff. And someone's saying some other recommendations. I will check those out next time. And in the meantime, probably mess around with them on my own too. There will be more streams of this sort in the future because people like the graphing ones. But for now, I am going to take off. And thank you all so much for watching. I will be back with some form of thing tomorrow. And if you don't catch me then, have an awesome new year. Learn some cool stuff. Party a good amount, but not too hard. Hopefully find something fun to do with your friends, or on your own, or rewatch all my videos if you have nothing to do, because I love you. So, I'll catch you later. I'm going to log off the stream now, but you are the best, and